Hi, this is Wendy Lightheart, and today we're going to look at multiplying and dividing rational expressions. First of all, for multiplying rational expressions, if P, Q, R, and S are polynomials, including constants, where Q does not equal to 0 and S does not equal 0, because then we'd have 0 in the denominators, then if we multiply P over Q times R over S, the result will be P times R over Q times S. In other words, we multiply the tops together to get the new numerator, and we multiply the bottoms together, and that will give us our denominator. Here's an example of two rational expressions that we're multiplying together. So we multiply the numerator together, we multiply the denominators together, and here is our result. And then of course we could distribute the 2 and distribute the 7x to get another form of our answer, which would be 6x minus 8 over 7x squared minus 35x. So either one of these answers would be considered correct, and that's because there are no common factors that could be canceled in order to simplify. So first let's look at how we multiply fractions. Remember that when we multiply fractions, usually we want to cross-reduce before we actually perform the multiplication. So we would factor everything completely so that we can see those common factors that we could cross-cancel. So notice we have some 5s that can cross-cancel, and we have some 2s that can cross-cancel. So again, we're just looking for common factors in the top that can be canceled with a factor on the bottom. Once you have canceled all the common factors, then you multiply everything that's left on the top to get the numerator and everything that's left over on the bottom to get the denominator. So all we have left on the top is a 5, and the only thing we have left on the bottom is 3 times 3, and this would simplify to 5 over 9. Now this is the same process we're going to use for multiplying rational expressions where we have polynomials. So for example, here we have two rational expressions we're going to multiply. And before we actually multiply, we're going to factor everything first. Factor everything completely before you start multiplying your rational expressions. So we can factor the 2x minus 10 by factoring out a common factor of 2. And then I noticed that I have a common factor of 3 between the 3x and the 12, so I'm going to factor out a 3 out of each of those. So when you're working with constants, oftentimes you don't have to necessarily break them down to all their prime factors. You can see what common factors there are that you want to factor out, and that's enough. So now we can cancel our common factors that we see diagonally, or if we also saw any within the same fraction, top and bottom, we could also cancel those. So notice that we have 3's that will cross-cancel, and we have factors of x minus 5 that will cross-cancel. And that is all that we can cancel, so now we multiply everything that's left across the top and everything that's left across the bottom. So we'll have just an x on the top, and then 2 times 4 on the bottom gives us an 8. So this would be our final answer. Now if everything cancels on the numerator, then make sure you leave a 1 in the numerator. You can never leave the numerator empty. However, if everything in the denominator cancels, then you simply don't need a fraction bar anymore, and you just are left with the numerator as the answer. Now let's look at dividing rational expressions. If P, Q, R, and S are polynomials, and of course we can't have Q, R, or S be 0 because those are all in the denominators here, then if we want to divide the fraction P over Q by the fraction R over S, then remember that to do this, just like with regular fractions, we change the division to multiplication. That would be our first step. Then we would flip the second fraction, and it's always the second fraction as you're reading from left to right that gets flipped. And so that r over s will become s over r, and then we perform our multiplication as usual. So let's look at an example. Here we have the rational expression x plus 5 over 7 divided by the rational expression 4x plus 20 divided by 9. So the first thing we want to do, remember, is to change it to multiplication and flip the second fraction, or the second rational expression. So the 4x plus 20 over 9 will now become 9 over 4x plus 20, and we're now multiplying those fractions together. And when we do that, remember, we want to factor everything completely before we actually perform the multiplication, because we might have some common factors that can cross-cancel, and it's much easier to find those common factors and to factor everything before you do the multiplication versus doing it after the multiplication. So notice that we have common factors of x plus 5 in the numerator of the first rational expression and the denominator of the second rational expression. So we cross those out, and so all we have left on the top is 9, and then we have 7 times 4 in the denominator to get 28. So that's it for today. So just remember, when you're multiplying rational expressions, you're going to factor everything completely first. Then you're going to cancel any common factors that you see on the top that match a factor that you have in the bottom. And then you multiply the numerators together to get the numerator of your answer, and the denominators together to get the denominator of your answer. And then dividing rational expressions is very similar to multiplication, because we change it to multiplication first and flipping the second fraction. Then we just perform the multiplication as usual, where we factor everything completely, cancel any common factors that you see in top and bottom, and then multiply what's left. So that's it for today. Have fun multiplying and dividing rational expressions.